Hi guys, and welcome to AP problem number 9. This one is a pH curve graph, and it's asking, show the results, or the graph below shows the result of titration of 25 milliliter sample of 0.10 molar solution of a weak acid, or HA, with a strong base at a molarity of 0.10 molarity of NaOH. And so here we see the darker graph is the graph that it was given. The graph I've written down is for part C. So the question letter A says, describe two features of the graph above that identify HA as a weak acid. The first point that can show us it is a weak acid would be the initial point right there at a pH of 3. So the initial point is where no milliliters of NaOH or any base has been added. So it is just the acid. And if it was just the acid in water, it would disassociate completely, having a pH of 1 if it was strong. However, we can see it is at a pH of 3, therefore meaning it is a weaker acid and doesn't disassociate completely. The second place we can see that it is a weak acid is the equivalence point. The one on top, not lower. See, the one on top is at a pH of 9, not 7. If it was at 7, it would be a strong acid, strong base titration, which would completely neutralize the ions, creating water. However, since it is a weak acid, strong base one, the equivalence point is higher than 7, meaning there is more OH minus ions there. On to B. Describe one method by which the value of acid dissociation constant for HA can be determined using the graph above. So that is a fancy way of asking to find the Ka. So the way I did was I used the initial point. The initial point is the point where no OH minus has been added through the base. So it is just the acid, which is what we want for Ka. I take the pH and I put it in the formula that it is Ka is equal to 10 to the negative pH, and in this case, the initial point being 3, I'd plug in a 3 up there. So you get Ka is equal to 10 to the negative third, which comes out to equal a Ka of 0.001, or, that's not enough, that's or, 1.0 times 10 to the negative third, which is the Ka value. Now we move on to C. On the graph above, sketch the titration curve that would result in a 25 milliliter of 0.10 molar HCl were used instead of the weak acid. So we see on the graph, I have drawn in what it would look like. So its initial point would be at 1, since it would completely disassociate, not slightly, it would completely disassociate having a pH of 1. And it would also stay lower and come up right around there. The other difference you can see is the equivalence point has dropped by a pH of 2. This is because the strong acid, strong base neutralization comes out to be water. Therefore, it would have a pH of 7 at 25 milliliters added. And then it just meets back up for the same endpoint. Now we move on to D. D is asking, or D tells us that what if a 25 milliliter 0.10 molar HA is titrated using a 0.20 molar NaOH. Letter I says the volume of the what volume of the base must be added to reach the equivalent point. So since this molarity is double that molarity, we can assume that it would just be halfway in between what it already is. So pretty much it's going to be somewhere between 10 and 15, because 25 and 0 is close to 10, 15 in the middle. The way we can find this mathematically is by using, we have the 25 milliliters of the weak acid, and we multiply it by its molarity to get the millimoles. So it's 2.5 millimoles of the weak acid. and at equivalence point, they are the same. So it is equal to the 2.5 millimoles of OH minus. To find the milliliters, you just have to divide it by its molarity. So you divide the 2.5 millimoles of OH minus divided by the 0.20 molar, which gets you a 13 milliliters. This is the amount of volume it would be needed to reach the equivalence point when using a 0.20 molarity NaOH. And then it says the pH at equivalence point for this titration is slightly higher than the pH at the equivalence point, and the titration used in the 0.10 molarity NaOH. Explain. So this is pretty simple. Since the titration is using a 0.20 NaOH, it requires less of it. So the total volume at equivalence point is only 37.5 milliliters instead of 50. Therefore, that means there's a higher concentration of the conjugate base, or A minus, and a higher pH because it is more basic. So that pretty much wraps up AP Problem 9 here. Thanks for watching.